I want to start with a short story. Back in the days when I was developing AngularJS, our back then manager came to us and told us, well, this application you built, and it was a quite large application with dozens of modules and thousands of lines of code. And he came to us and told us, it doesn't work on my machine. And we were sure it works on your machine. We were a startup, we were just a few developers, and we showed him that it worked on our machines. We had 16 gigabytes, quad core, some really fancy shit. He had a really old laptop. And we told him he needs a better laptop. We were lucky that day that he just used that as an excuse to buy a better laptop, but right after he left, we realized we have to fix something. This is where we came up, first came up with the idea of how can we lazy load stuff in our application. Back then we used an application called library called OC lazy load with Angular. Now it's part of the core itself. So I want to talk about lazy loading and strategies you can use to do it in really large scales. Who am I? Sebastian already introduced myself. My name is Martin. I work for a company called Sinnerschrader. We are building stuff for many clients and have a lot of time to go deep into really complicated topics like how to do lazy loading. I'm also the organizer of the Angular Berlin meetup and one of the organizers of the upcoming NGDE conference in Germany next year. Next to that, I'm really into math. That's the reason I studied math. I love coding. That's the reason I do my job. And I love cats. And, well, I used a bluish picture, but this is my cat. His name is Chaos Monster, and luckily that's also my Twitter handle. So, performance using lazy loading. Short question, can I get a hand raise? Who used lazy loading in Angular? Awesome. Who used custom preloading strategies in Angular? Okay, a little bit less. Really short, what is it all about before we go into the really important stuff? It's to optimize your startup performance time. It's to minimize your initial app size. So the first the first paint is faster, and it needs routing modules, and you can use preloading strategies to manage the fetching of the lazy modules. In a nutshell, lazy loading looks like this. You need a module that has route childs, and you need, in your for root routes, you need to call them with load children. You can pass them data, and that's it. Lazy loading, we've done that, less than a minute. Preloading strategy in a nutshell. Preloading strategy is just the second parameter when you define your routes in your router module. And you have two default preloading strategies. The first one is the one that actually ships with lazy loading, is preload nothing. So you only load modules when you hit a route. And the other one is preload all modules. That means every time you start up your application, it will catch all the modules you have. So how does custom preloading strategies in a nutshell look like? It's nothing else than a service where you implement a preloading strategy interface, and you get one method where you have, you get a route, and you return an observable. The really awesome part about observables here, you don't have to decide right when you call this method if you want to preload something or not. You can delay it to some point into the future. And that is what we used later on in our application to make it work better. So when do we need more? When your customers have low-end devices, or if your users have low-end devices, you might not want to load everything for them, because if you run a really large Angular application in a computer with only 2 GB of RAM, I can assure you it will crash. I tried it. Or if you have slow connections, so whenever you have a phone and the phone only has 2G or 3G or something like that, you don't want your user to load everything. You want just to load whatever is needed, because slow connections means it takes some time to load everything. And of course, the main issue, we looked into it, large applications with a lot of routing modules. That means if you have application with dozens and dozens of routes and modules, you might want to look into that just to make it a little bit easier for yourself and your users. Or, of course, combination of all three of them. So, slow connection. Wouldn't it be easy and really great if there would be an API in your browser that tells you on what internet connection you are? Well, it turns out there is. It's navigator connection effective type. It returns a string that is either 2G, 3G, or 3G fast, and 4G. But the thing is, it only exists in Chrome, and it doesn't work on any other. So, yeah, would have been great. There's this thing called web speed pages. Do you know one of them? Not a specific one, but you know web speed pages? Can I get a clap or a hand sign, something? Yeah? Yeah, okay, you know them. The way, okay, that was irritating. The way they are working is they download a lot of stuff and just take the time and then calculate your speed. If you're on a slow internet connection, and especially if you want to perceive the performance for your application, you don't want your user to download, I don't know, megabytes and megabytes of stuff. But what you can do is you can just use your index HTML file and make the first thing JavaScript hits date get time, what gets the current date, and save it into a variable. And then find some place in your application where you know how much kilobytes of stuff were transferred. Like, for example, after the polyfill TS file. And then you get the second time. And then you have the timing that it took to download the polyfill file and maybe some other stuff. And this is quite some concise stuff where you can do that over and over again. You get almost the same results. And this is what it would look like. You would have just a super simple get time package, do it in a start time, and the other one. And then you can use the load up time in your preloading strategy to define if you're on a fast and a slow, on a fast or slow connection. Low-end devices. Would it be awesome if there's an API for that? Well, it turns out there's no real API to detect what kind of device you have. But there's a lot of informations if you're looking at various APIs. For example, the window navigator provides a lot of information, and you can find out how many CPUs a machine has. You can find out if it's a Chrome, if it's a Safari, if it's an Edge browser, if it's an IE browser. You can find out if it's which platform it is. So, for example, if you see that it's a Safari, you can be sure that it's not that bad of a machine. If you see an IE8, you just can run. But yeah, you have your way around there, and you can also use this information to define which parts of the preloading you want to have. Halftime. Let's talk about really interesting stuff. User behavior. So, in a large application, your user won't hit all the modules all the time. The user will only go to one module, maybe to the next one, and maybe to a third one, and maybe to a fourth one. But you won't use all the modules you have. So you want to know how your user uses your application, and you only want to use to load what your user really needs. And you want to do that to give your user a great performance, perceived performance of your application. Because if you do not load it, like with no preload nothing, it takes some time until the module is loaded, initialized, and so on. So a click on a link can take up a few seconds in worst case. You don't want that. You want a smooth, perceived performance in your application. So you want to know what you load next. And this is really good, and let this be a warning. Don't try this with a small application. Use it when you're going really large, because you have to collect a lot of data. You have to collect, do a lot of stuff around this to work. If you have a large application, large scale, this is a great idea to use it. So in a perfect world, you would have just one way through your application. You would have a funnel. So you have module A, you have module B, C, D, and so on. And the user is only able to go from module A to module B and module C. So in this perfect world, you could start with module A and tell, okay, if the user is on a website, on a page with module A, load module B. If the user's on a page with module B, load module C, and so on and so forth. But I think no one of us has an application that looks like this. In reality, it looks a little bit more like that. You have some top-level navigation where you can jump from module A to module B and to module C. Maybe you can jump from module B to module C and F, and so forth and so on. So when I first saw this, this reminded me of something I learned in university when I studied math, and it was machine learning. And it wasn't the fancy new part of machine learning with neural networks. It was something that is less fancy, more usable and easier to use if you understand it. It's Markov chains. And A, they're really simple to use. B, they're really simple to understand. And C, you do not need to have a neural network if you know what you want to achieve. And if you look at a Markov chain, this is our current mesh we have with all the modules. Markov chains do nothing else than add the probability of the user going from module A to module B. For example, in this application, the probability to go for a user to go to module B is about 80%. And if the user is in module B, the probability is about 70% to go to module F. So this looks a little bit complicated. You can use that, but you can also make it a little bit simpler, like a two-dimensional array. So you have your modules from A to F, and every time there's a transition from one module to another module, like for example from A to B, you just write down the probability of the user using that route. And what you're doing, if you're in module E, for example, you just look for the exact row and find the column with the highest probability and load that module. So this is Markov chain in a nutshell. This was machine learning. If you understood that, you understood machine learning. Don't let anyone tell you otherwise. This was machine learning. You can make it a little bit more complicated and take into account what route the user took before. So if the user came to module F via module B or via module C, or so on and so forth. But in a simple nutshell, this really helped us to get really awesome perceived performance and to not load everything we needed. And in our case, it weren't 6 modules, it were about 60 modules. So in a bigger scale, it really helps. So how would that look in Angular? Okay, here comes a little bit of code. But again, this is an entirely working service that can tell you what to have next. So you just have to imagine there's a model that is a two-dimensional array, and then you ask the service get next module, and you tell it the current module name. It finds out what row you're in. It tells you which column has the highest ID, and that's it. You may want to have an update current module method to tell it what module is currently loaded, but this works, and I have a working example of this at GitHub. You can check it out later. And for the custom preloading strategy, you just have to implement a preloading strategy that uses the preload method and uses the strengths of observables. So the observable itself just asks the next state of the service we just created. If the current module name is the name of the next highest ranking, and then we just load it. And otherwise, we just wait. We don't tell the router to not load it. We just wait until we are either hit it anyway or until some route says this is the next highest probability. Conclusion. Less than 3 minutes. Awesome. Who was it with the point landings? Okay. Large applications. Low-end devices and slow connections. What I just showed you is a super simplified version of what you can use when you have a really large-scale application, want to use preloading strategies to make it easier for your users to navigate around, to not mingle their bandwidth or to heat up their CPUs. It works if you have slow connections. The techniques I showed you can work to find out if you're on a slow connection device. And it can really improve the perceived performance, because most of the times your users will hit exactly that module next that you predict. And if not, well, it takes a little bit, but most of the time it will increase the perceived performance. If you want to ask me where to get the data, there's this thing called GDPR, so think about where to get the data, but Google Analytics would be a good place. If you have your own tracker like Piwik, use that one. Or you can use just the local store of the user and do it on the user's machine. But be aware, there's a lot of overhead in collecting the data and maintaining the data. Thank you.